Hello there folks, and welcome to video number 134. This video is on symmetry, and the keyword I've got here for you, or the key phrase I've got for you, is order of rotational symmetry. And what that means is how many times you can turn the shape around and it still looks exactly the same as it did at the beginning. Now there are two types of symmetry you need to learn. Lines of symmetry is the first type of symmetry, and that's where you can draw a line on the shape, a straight line on the shape that makes two sides of that shape look exactly the same. And order of rotational symmetry is how many times you can turn the shape around and it still looks the same as it did at the beginning. Okay, like I mentioned just before. So the first thing that we're going to have a little look at doing is drawing all lines of symmetry on the regular shapes that are below in question number 1. So I'll zoom into that one. Now if this is a regular shape, that means all the sides are the same length. This means it's an equilateral triangle, so you can do one vertical line straight down the middle. Okay, but you can also go through the corners and then the base of the triangle. So there would be 3 lines of symmetry there, because this side looks exactly the same as this side, and this side looks the same as this side, and so on. Okay, now this is a square. So there's one straight down the middle for the square. There's one straight down the middle, or across the middle. But then with the square, there's also these corner to corner, we call those diagonals. Okay, so one corner to the other corner, there's diagonals. Okay, there are 4 lines of symmetry on a square. Okay, this is a pentagon. Okay, it's a regular 5-sided shape, and this had 3 lines of symmetry, 3 sides. This had 4 lines of symmetry, 4 sides, and you probably guessed that this is going to have 5 lines of symmetry. So this is the first line of symmetry. Okay, then we've got the second line of symmetry and the third line of symmetry. We're just going from the corners right through the base of the shape. Okay, and there you go, there you have it. There's your 5 lines of symmetry. It starts to look more complicated the more sides the shape's got. Now this is a arrow shape. Now we just have one line of symmetry that goes right through the point of the arrow. Okay, this side looks the same as this side, and that's all you can do. All right, so there you go. That's lines of symmetry. Relatively simple stuff. All right, I will zoom out of that and I will get rid of that so I can write on for the next question. So in number 2, it asks us to state the order of rotational symmetry for the shapes below. Now this first one is a circle with an arrow shape inside of it. Now can we turn this round and have it look exactly the same as it does at the beginning? There is no position that you could do it other than turning it 360 degrees and getting it back to the starting position. Okay, so for this question, you could state that it's got an order of rotational symmetry of 1, or you could say 0. Okay, don't put both, just put one or the other. All right. Now this shape here is 8-sided, and it's regular 8-sided shape because all the side lengths are the same. Okay, now if we started at this point here, okay, there's 1. That one, we turned it to the left. That bit was at the top, right? It would still look exactly the same. Now we could do that 8 times because it's got 8 sides of the same length. Okay, therefore has an order of rotational symmetry of 8. Okay, and now this one, the last one, this sort of radiation symbol, I think it is. We've got 1, 2, 3 parts to it, round a circle. All right, and basically it's a case of, well, that, and that look exactly the same. So it's got an order of rotational symmetry of 3. Okay, relatively simple once you understand that key phrase. Now the third and final question. A little bit of logic required for this one. So in number 3, we've got to shade in 3 squares so the shape below has 1 line of symmetry. Now initial thoughts probably would be, well, I'm going to try and think of a line of symmetry going straight down the middle. Can I shade 3 squares in? Where we'd have to shade that one in to reflect this one. We'd have to shade this one in to reflect that one. We'd have to shade that one and that one in to reflect these 2. All right, as I should have mentioned earlier, probably that symmetry is reflection, same thing. Okay, so we can't put one down the middle. We can't put one horizontally across the middle because that reflects that. That's fine. All right, then we'd have one there, then we'd have one there, and then we'd have to make one up. Right, now we'd have to kind of split the middle, and that's possible to do, but it says we've got to shade in 3 squares, 3 whole squares. So let's have a diagonal mirror line here. Okay, now this one has to be reflected over here, so that would be my first thing to do, just shade this square in here. Right, and then we've got that one reflecting that one, which is fine. So let's just have this one shaded in here. okay, because half, if we weren't splitting through the diagonal, we'd have that half is reflected in that half, and then we could just shade this one in here as well. Okay, we could have chosen the one down the bottom here, but if I just kind of sketch the mirror line in, or the line of symmetry, could be referred to as a mirror line. There you go. You can see that that is 3 squares shaded in. That has satisfied our question. All right, so hopefully that video has helped you understand symmetry just a little bit better. Please click the link in the description to practice yourself, yeah, like, subscribe, and all that stuff that is normally said. Thanks so much for watching. I hope you watch another one. Take care. Bye bye.